I thought what I'd do this afternoon, in view of the shortness of the time, is to review just briefly the status on the O+ observations that we have made, and then to present some more recent results on the observations of helium, energetic helium+ ions, and then finally to comment on the significance of both of these, at least as I see it. The first slide is just an example of some energy spectra taken during the December 17th, 1971 magnetic storm with an energetic ion mass spectrometer that covers the energy range from 7/10 of a kilovolt to 12 kilovolts. This was a velocity filter in front of an electrostatic analyzer, which provides one a measurement of the mass per unit charge at a given energy. So we have a mass spectrum at each of 9 energy points over this energy range. The reason for showing this is that it's an indication of the range of characteristics, spectral characteristics. At times the fluxes are indeed very soft. The intensities can be fairly high. This is a differential number flux. This is an intermediate case which seems to have a low tail as well as a harder component, and then one which has essentially only a hard component. I should emphasize that these are observations made on a polar orbiting satellite at 800 kilometers, and the instrument is looking at 55 degrees to the zenith, so it's sampling precipitated particles. After looking at this one storm, the question comes up as to what is the local time characteristic of these fluxes. Are they there in all magnetic storms? We, from a very quick survey, concluded that they were primarily storm associated. We looked at 12 storms during the period from December 1971 until mid-December 1972. We looked at them in a synoptic sense, that is, we took 3 passes of data in each of the storm spread out over the storm time. The next slide will show a summary of that data, plotted as a function of magnetic latitude, 80, 70, 60, 50, and local magnetic time, noon being down here and this midnight. The lines themselves indicate the region over which we observed the energetic oxygen ions above the background of the instrument, about 10 to the 5th ions per square centimeter per second per steradian. The dot indicates the position of the peak intensity of the flux. Now from this slide, one can see 2 things rather clearly. One is that these energetic oxygen ions are precipitating at all local times, albeit over a number of storms, because on the low altitude satellite we are precessing only 2/3 of a degree per day, so it takes about 9 months to precess fully around to get a full local time sampling. The other thing is that the region over which it's precipitating is also very large. We see orientation with respect to essentially the trapping boundary or the lower edge of the auroral oval, for example. I don't have time to show other data to show that in more detail. Now, a point I'd like to make here is that the very wide local time spread, the very wide latitudinal spread, to me would seem to make it very difficult to explain these ions as essentially originating from a source, and we're seeing them immediately after being injected and accelerated. The reason for that is that the ionospheric characteristics vary widely in latitude, in local time and in latitude, and the magnetospheric characteristics also vary widely in latitude and local time. Therefore, to have just the right conditions to inject and precipitate the fluxes over this wide region seems unlikely. Therefore, I conclude that there's probably a large amount of transport going on, and therefore, even though we're looking only at the precipitated component, there probably is also a sizable trap component that is taking part in the transport. The main thing I'd like to note here is that the ions do seem to be, when they are not spread all over, inside the trapping boundary. They also seem to be fairly well correlated with the very soft inner edge of what we would consider here to be the plasma sheet electrons. This was a local time of about 2030.
I wanted to just say a few words about Dick Johnson and about this measurement. And I mentioned earlier this morning, and others have, the significance of the Lockheed measurements of the very high energy particles, which were obviously from the ionosphere, in terms of just changing the perception of what all is going on. These instruments were very, very rudimentary. Of course, it was a long time ago, but they were electrostatic analyzers that had just one little magnet in front of the electrostatic analyzer, ceramic magnet and a yoke that would just let one type of ion through into the electrostatic analyzer. So there was no mass spectra or anything like that. They would have to pre-flight tune these magnets to just let one kind of ion through. So it was a very successful measurement, and as I said, very, very led to a very strong change in what people thought about the ionospheric role. On a personal note, when I finished my PhD thesis, I was fortunate enough to be hired at Lockheed and by Martin Walt. And when I first went there, I worked for Dick Johnson and Dick Sharp and Ed Shelley in that group, which was a real pleasure. And there was after about a year, because of the way the data analysis money was going and coming, there was not enough. It started to get financially tight for me to keep working with this group. And it just so happened that at the same time, Jerry Sharp, who was also at Lockheed, had built an instrument for the OGO 5 satellite, the light ion mass spectrometer, which was a low energy particle detector. And so Dick said to me, you know, you might want to go up, and knowing that there wasn't enough money to keep paying me to do what I was doing, he said you might want to go up and talk to Jerry Sharp, because they have, you know, this instrument's working well and they have some money for data analysis, so you might want to try that. So of course I did, and I enjoyed it very much and did it for the rest of my life. So I owe that to Dick and to Martin and to Ed Shelley and Dick Sharp, and certainly Jerry Sharp, in terms of the wonderful instrument that they built. So Dick's a very special guy. I had lunch with him on Friday. He sends his regards to everybody. Very distinguished career, where he was at one point the acting science advisor for President Reagan. So a very successful gentleman.